In this lesson, we are going to talk about curved mirrors and ray diagrams, which are going to be used to find the image of an object that is placed somewhere in front of our mirror. So the first thing we need to understand about curved mirrors is that if we just take a circle, the very center of the circle, that C, we're going to call our center of curvature. So if we have a curved mirror, it's based off of a full circle. If this were to go all the way around, this C, that would be our center of curvature. That would be dead center of the circle. The next piece we need to understand is that half the distance from that center of curvature to the mirror, right smack in the center, is we're going to have a focal point, this F point right here. So your C, that would actually be the radius of the circle if it were to go all the way around, and the F, that would just be half of that distance. So really 1/4 of the way, all the way across the circle. So this line right here, this is called the principal axis, and it runs through the center of curvature to the focal point, and then it's going to hit our curved mirror at a 90-degree angle, at a normal angle to that surface. And if we send any light rays parallel to that principal axis into our curved mirror, runs parallel to the principal axis, it hits the mirror, and then that light ray is going to reflect off our curved mirror and go through or at the focal point. That's why it's called the focus or the focal point, because all those parallel rays focus on that point. So another thing to understand about the center of curvature is that if we take any light ray, any ray, and make a line directly at the curved surface, it's going to hit at 90 degrees or perpendicular or normal, and then it would bounce straight back. Since it's hitting at 90 degrees, because of the law of reflection, it's coming at an angle that's 0 degrees from the normal. Law of reflection states that the angle of incidence is going to be equal to the angle of reflection, again measured from the normal. So it's going to go straight along that line, it's going to hit the mirror, and it's going to bounce straight back. It doesn't matter if we go here or here or here, it's going to hit and it's going to reflect straight back along that same pathway. So when we're going to do our ray diagrams, we're going to use these to find our image. So we're going to look at a couple examples, and with the ray diagrams, we're going to use 3 different rays. We're going to use a parallel ray or a P ray. We're going to use a focal point ray or an F ray, and we're going to use a center of curvature or a C ray. So let's look at what this would actually do. So in this first example here, let me zoom out a little bit. In this first example, we have an object that is located pretty far away from, in this curved mirror, we're going to call a concave mirror, because we're looking into, if you think of, in this case, the opening is facing towards us, just like the opening of a cave. The next example we're going to look at, this is for a convex mirror. This is where the object is here and the mirror is facing, the opening is facing away from us. So we're going to start with a concave example. Again, looking into the cave, it's curving towards us, and we're going to draw our 3 rays. So we're going to want a straight edge for this. And again, these ray diagrams are going to enable us to find, based on where this object is located, where are we going to find our image? What is our image going to look like? So here we go. We're going to draw, first we're going to draw our parallel ray. We're going to start right at the tip of the object, and I'm going to make a line that is parallel with our principal axis, this line right here that runs through the C, the F to the mirror. I'll do my best to draw this parallel. That's why we use a straight edge. And that is going to hit our mirror. And since it's parallel, it will then reflect and bounce back through our focal point. I'm just going to extend this a good ways. And the next ray we're going to do, this is the focal ray. So this starts at the top of the object. It goes through the focal point. And our F ray, this focal point ray, let me just label, this was our parallel ray, so P. Our focal ray, it's going to go through the focal point. It's going to hit the mirror. And then it's going to bounce back parallel. So this is pretty much the exact reverse or opposite of what our P ray did. Parallel ray starts out parallel, goes through the focal point. The F ray starts out going through the focal point and then bounces back parallel. So pretty much the complete reverse. And then the third ray that we're going to draw is our center of curvature ray. And because we're starting at the object and going right through the center of curvature, it's going to be hitting the mirror at a 90-degree angle, and that's just going to bounce straight back. So we don't even really need to trace back that line. It comes in and it reflects right back out. And this is going to be our C ray. So what we should notice is that after those three rays reflect, they converged at a certain point. And where they converged, this is where we're actually going to find our image, the image of our object. So what we do is we start at the base. The image is going to start at the base of the object, and we're just going to draw it to where those points converge, or where those lines converge. The better you draw your rays, the better convergence point you're going to have. And we just draw our image. And in this case, our image is inverted. It's upside down. We could see that it's a smaller image than what our object is. Here's the size of our object here. The image is much smaller. We can see that. And since this image is also on the same side of the object, this image is actually going to be projected out into the real world. This is going to be a real image that we can project onto a physical screen. And we'll do some examples of this in class as well. But this is a real, inverted image that is smaller. So there are going to be other times, depending on where this object is located, compared to where our C and our F points are. If we move this object further inside here, some different things could happen based on where these reflected light rays converge. For a convex mirror, we're going to see that the same thing is going to happen over and over again, because no matter how we move our object, since the center of curvature and the focal point are on the other side of the mirror, and we'll talk about what the other side of the mirror means in a moment, but we can never get inside of the center of curvature or the focal point for a convex mirror. So in this case, the same thing's going to happen over and over again, no matter where we put our object. If we get it closer to the mirror, further away from the mirror, we're never going to be inside our focal point or our center of curvature. So the same thing's going to keep happening. So we're going to draw our three rays again here. And something a little bit different is going to happen with a convex mirror. And it could also happen with our concave mirror occasionally, but here's our parallel ray, parallel to our principal axis. It hits the mirror, and it would want to go at the focal point. So I'm going to line up my ruler like it's going at the focal point. But since it's a mirror, it's a reflective surface, it's going to reflect, it's going to bounce back the other way. And there's our P ray. Our focal ray, we're going to line up like we're going right at focal point. But since we run into the mirror before we get to the focal point, just like with this one, it's going to hit the mirror and it's going to reflect back, and our focal ray reflects back parallel. It's the exact opposite of our P ray. So there's our focal ray. and then our center of curvature. We go right at the C, and again, when we hit the mirror, it's going to reflect, so it would go back this way. Try to make that as best we can. So there's our C ray. But what we should see is that unlike our rays here, where they all converged at a nice point, our P ray, our F ray, and our C ray, when they're reflected, they're never gonna converge on this side of the mirror. Out here in the real world, they would never converge. So behind the mirror, what we're gonna do, since they would never converge on this side, we're gonna extend those rays. So the parallel ray would have gone at the focal point. All we're going to do is we're going to extend these rays, and I'm going to do this with dotted lines. So the P ray would have gone like this if it could get through the mirror. Our focal point, or F ray, would have came back parallel. So it would have gone like this if we were able to go through the mirror. And our center of curvature ray, that just would have kept going right at the center of curvature. So they would have never converged on this side, but if we extend those rays, we see that they would converge over here. So we're just going to go based off of that, where these converge. And we get an image. Again, we start here, draw our image up from the principal axis. And we get an image that is the right side up. This is pointed up, this is pointed up. Again, our image is smaller. But since our image exists on the opposite side of the mirror from where the object is located, anything on this side of the mirror is technically in mirror world. It doesn't really exist. This is a virtual image. A real image like this that's on the same side of the mirror as our object, that's a real image that we can put onto a screen. This is a virtual image. We can only see these images in the mirror. We can't project them out into the real world onto a screen. So this would be a virtual, upright, and smaller image than what the object is. And once again, convex, since we can never get the object inside of the center of curvature or inside of the focal point, because those things exist on the other side of the mirror, we're always going to get the same result. These extended reflected rays will give us an upright, virtual, smaller image. And we'll talk more about why each of these different types of mirrors are important for different purposes. But this is the basics of how you can find an image using ray diagrams.